In our last section of Chapter 8, Rational Exponents, we're basically going back a few chapters to all those exponent properties and kind of relating it to what radicals really are. We've talked about this a few times throughout the sections of how a radical can be written as an exponent and vice versa. We talked about, as you can see right here, how the numerator is really the exponent of the radicand, and the denominator is the index, and vice versa, and how you can write that. Now, in this example right here, we have the numerator is just 1, but remember that can also apply with any number. So if I have something like this, a is the radicand that goes underneath the radical, the m becomes the exponent of the radicand, and the n, again, is that index. One thing to also note, you'll notice that I put the exponent of m kind of underneath the radical. It really can be written either way. I can write it next to the a just like that, or it can really kind of go on the outside. They're kind of interchangeable. We can kind of use that to kind of make solving rational exponents easier. So if we have a problem like this, when we have radical notation, we can change it, or I'm sorry, rational exponents, we can change it to radical notation, just like we did at the top. 100 is the radicand, so it goes underneath. The index is 2. You don't have to write 2, but you can. And the exponent is 1, which again, you can write or not write because it's implied. So basically, 100 to the 1/2 power is really the square root of 100. Square root of 100, hopefully we all know, is just 10. Here we have one that's slightly more complicated. We have 64 to the 1/3 power. We're going to change that into radical notation, and I'll put 64 to the 1st power. But this time our index changes a little bit. Our index is 3. So now instead of square root, we're looking for a cube root of 64. So what number times itself 3 times gives us 64? It's going to be 4. Go ahead and pause your video for a minute and go ahead and see if you can do 3 and 4 by yourselves. For number 3, the key thing to realize is that the negative is surrounded by parentheses. So that is the radicand itself. So we're going to do the cube root because our index is 3. And the negative goes underneath because it's within the parentheses. And that 1 is our exponent. What is the cube root of -8? Well, we can do cube roots or negatives because it is a cube root. That's going to give you -2. For number 4, what you're going to do is you are going to, again, apply the radical to the entire quantity, which is 4 over 25, 2 being your index, 1 being your exponent. But because it's 1, it doesn't really matter too much. Same with that 2, it's implied for the index. When you have a fractional radical, remember you can apply it to both the numerator and the denominator. So we're going to get 2 over 5 as our answer. Again, why don't you go ahead and pause number 5 and number 6 and see what you come up with before we start doing it together. All right, in number 5, we're going to change that to a radical. Index is 2, 16's our radicand, and 3 is our exponent. Now, what you could do is you could do 16 cubed and then do the square root of that number. But remember how earlier in the video I said these are kind of interchangeable and how you approach those steps. So what we're going to do is we're going to write it like this. We're going to do the square root of 16, and then that's going to be raised to the third power counted on the outside. By doing that, that makes the numbers more workable without a calculator. Square root of 16 is 4, and then if I raise that to the third power, we get 64. I'm going to do something very similar with number 6. The index in this case is 4. It's 16 to the third power, but I'm going to do that radical first because they are interchangeable. I'm going to do the fourth root of 16 and then raise it to the third power. So the fourth root of 16 is actually 2. 2 times 2 times 2 times 2 is 16. Raise that to the third power and you get 8. You'll notice that it's much simpler than trying to do 16 times 16 times 16. You're going to end up with a huge number and then trying to figure out what the fourth root of that is. Again, pause the video for a minute, see if you can do number 7. Number 7, in this case, what you have to watch out for is that negative sign being on the outside. So when I do this, I'm going to do the cube root of 27 squared, and that negative sign goes on the outside. Just like the other ones, what I'm going to do first is I'm going to do the cube root of 27. It's going to make it an easier number, which ends up being 3. And then I'm going to drop down the exponent and square it. Again, I'm squaring that 3, not the negative, so it's going to be 9. Drop down the negative, so the answer is negative 9. Another thing that should be review is when you have a negative exponent. Remember, we don't like that formatting, and what negative exponents really mean is that you move that radicand around. So if it's in the numerator, it moves to the denominator, becoming positive. And again, that should seem as a review. So before we start things, if we see a negative exponent, we're going to change it to that format. And to finish up this video, we're just going to do a few examples of these very quickly to go over that. I suggest it would be a good idea to pause it, do all of them real quick, make sure you have a feel for it, because I feel most of you know how to do the exponents already before we do it together. So in number 1 with that negative exponent, I'm going to change that to 1 over 49 to the positive 1/2 power. And then I'm going to go ahead and change that exponent into a radical. So it's going to become the square root of 49. And the square root of 49 is 7. So our answer is 1/7. Number 2, same sort of thing. I see a negative exponent, so I'm going to make that positive by moving it to the denominator. So it's 1 over 81 to the 3/4. I'm going to change that exponent to a radical. And because this is such a large number, what we're going to do is we're going to do the radical first. And the fourth root of 81 is 3. So then we have 3 to the third power, which is 1 over 27. Number 3, hopefully you'll notice the negative is outside, so we don't have to do anything different. This is like a previous example. I do the negative on the outside, and then I'm going to do the square root of 16, which is going to then be negative 4. So again, make sure you notice the difference between a negative being in the exponent versus on the outside. And then let's go back to a few of the properties that we talked about previously. If we have the same base, and we're multiplying, hopefully remember that you add those exponents. So this becomes 5 to the 3/4 plus 5/4, which becomes 5 to the 8/4, which is really 5 squared, which is 25. If we have an exponent to an exponent, we're going to multiply that. So that was 1/5. So it becomes y to the 1/5 times 15, which becomes y to the 15 over 5, which is just y to the 3rd power. And these are our last two to wrap up, division. And if you remember from division, what you're really doing is you're subtracting. So you're going to get x to the 2/3 power minus a negative 4/3. So the double negatives make it a positive. And you get x to the 6/3, which is x squared. Same sort of thing for our last example. 13, because it's division, we're going to subtract those exponents. And you get 13 to the negative 2/4, which is 13 to the negative half. Because it's a negative exponent, we're going to do 13 to the positive 1/2 in the denominator, which is 1 over the square root of 13. And one last thing to make it a little bit trickier is we have a radical in the denominator. So if you remember back a couple lessons, we can't have a radical in the denominator. So we're going to rationalize and do square root of 13 times square root of 13. That gives you square root of 13 over 13 for our answer.